in some of the earlier videos, we've established that the number e is given by this or given by this. These two are in effect the same, but just written differently. And the way to find the number e is to find something that when you log it, it gives you 1. That's a trick into finding out the number e. To find the number e is for you to find out something that when you log that something, it gives you 1. Because when you're able to find something, when you're able to find something that when you log it gives you 1, then you can exponentiate both sides, giving you this here, and then the 2 will cancel out, giving you the bubble on itself, the bubble by itself, and then the e, you've pretty much isolated the e here. So e is given by this bubble here. So the way to find the number e is for you to find something that when you log it, it gives you 1. But the question here, the main question is, how did the first person know what to put into this bubble here in order to create the number 1? I mean, who would have thought that if you put these two into this bubble here, it would give you 1? I mean, if you were to try and sit here and guess what you would put into this bubble to create the number 1, it might take you a while. You could guess, oh, let's try the limit of let's say 3 plus x to the power of 3, maybe to the power of 1 over x to the power of 7, say. This here would not give you 1. It would not give you 1. But if you had to discover the number e, how would you go about guessing what to put into here in order to create the number 1 here? You see, the secret to finding out what to put into here is to look at this bit here. Hang on. So this is your graph here. This is your e to the power of x. This is your natural log. The secret to finding out what to put into that bubble is to look at this bit here. Okay, because in some of the early videos we've established that the gradient here is 1. So we started out with e. We started out knowing that e exists somewhere between 2 and 3, but we don't know precisely where. So we start out with e here, and then we in a way manufactured this natural log graph by reflecting it along the y equals x line. You see, because this gradient here is 1, that means the reflection at this point here will also be 1. So we know that the gradient here is 1. You see, the secret to finding out what was in that bubble is to look at this bit here. Okay, let's try and look at this bit here. Let's try and so this is our graph, our natural log. Okay, we know that the gradient here is 1. So we're going to try and work out the gradient. We're going to evaluate the gradient of the natural log at this point here. So hang on, let me go back a few steps. So our aim here is to pretty much guess what to put into this thing here to give us 1 here. I mean, if you were to sit here and just randomly guess, it might take you a while. So the secret to finding out what's in this bubble here is to look at this bit here. Hang on, is to look at this bit here and realize that the gradient here is 1. Okay, so hang on, let's evaluate the gradient here. Let's evaluate it at, so hang on, let's evaluate the gradient of the natural log at this point here. Okay, so set up our normal routine here. Our normal routine is to set up 2 points, A and B here. Okay, so don't forget, we know the gradient here is 1. We know that the gradient here is 1. Okay, so hang on, looking at the natural log here, the gradient here is 1. So we can now set it to 1. So this gradient here is 1. Okay, and then this, so our normal routine is to set up 2 points, A and B. So this height here is given by this. Take away this. This is our A here. This is our B here. Okay, so the height here is given by this whole thing here. Now we could call it delta x. So we could call this distance here delta x, or we could call it h. But let's just call it x, because x is going to go to 0 anyway. Later on, we simplify things. Okay, so let's call this distance here x. Okay, so we're going to take the limit as x tends to 0 of this thing here. Okay, so and don't forget, we know that the gradient at this point here is 1. Okay, so now hang on. So now so this bit here, natural log of 1 is 0. Okay, so you have this thing, take away 0 divided by x. So we can pretty much ignore this. Okay, so this whole thing here simplifies to this. Okay, so now visualize this here as 1. Well, visualize this thing as 1 over x times this thing here. Okay, so visualize this thing here as this thing here. Okay, that would then take you to this, and then hang on, and then well, if you have something like well, if you natural log of x to the power of a here, that's the same as well, you can take the a out here, so that's like this. So now we are working backwards. We are here, and then we are jumping back to this. So the point here is that well you can then take it, you can then work backwards to put this bit up here. Okay, so that's your, so hang on, so this here is this here. Okay, because when given this here, you can always move this down here. So we are pretty much working backwards here. We are putting it back up here. That is legitimate. Okay, so from here, that would then take you to here, and then well, you taking the limit of the whole thing here is the same as you can move this into here. Okay, because when you take the natural log of the limit of blah blah blah, you can actually move this out here. Okay, but here we're just working backwards. So it's us using one of the laws on limits. Well, anyway, from here, you taking the limit of this whole thing here is, well, you can actually jump into here, and then find the limit of this thing here, and then natural log the whole thing. So what we've done here is that we found we found something. So hang on, let's go back. We are here at the moment. So by using one of the laws, we can put this up here. Okay, that will then take us to this stage here, and then we can actually jump in the limit part here. Can jump into here. So now we've found something that when you log it, when you natural log it, it gives you 1. That's the whole point. You see, when you natural log this something here, it will give you 1. So we found something that, yeah, we found something that when you natural log it, it gives you 1. That was our aim here. Our aim right from the start. So this is our answer here. This is our answer here. So right from the start, we said that if you can find something that when you natural log it, it gives you 1, then you pretty much have yourself E. So going back to down here, we found something that when you log it, it will give you 1. We found something that when you natural log it, it gives you 1. And the way we did it was to look at this, was to look at this point here. The whole secret here is to look at this point here. We know that the gradient here is 1. So we worked backwards right from, just by looking at this here, we managed to find out the number E. Okay?